So we're at the Puma lathe, and I want to show a subspindle parts ejector very briefly here. You know, main spindle, subspindle. The part that I'm making has a big through hole, and through holes are a problem because chips can get into the subspindle, especially with these collets, and then on the next part, and on the next part, and on the next part. Eventually, you get some chips in there that get clamped on the nice outside turned finish, and it leaves an impression on your part. Or if you had tons of chips, you could get it jammed up anyway. So in here, we're gonna watch the part get ejected into the catcher cup. Ready for it? It's cycle start here. No, come on. Cycle start. There we go. Okay, so we just saw the catcher cup lifted and the chuck opened, and then this guy right here is, I'll show you that. It pushed it out into the catcher cup, maybe a little bit more aggressively than I would ideally like to see, but you know, didn't shoot it into the bulkhead or anything. And then you're gonna lower the catcher cup down and it dumps out on the conveyor belt. Now I'm gonna reset the program and let me show you. This is a very simple ejector. So in this case, it's kind of awkward because I have to really push, you know, there's, I don't know, 15 pounds of force or 20 pounds of force. So I gotta push the ejector in, and then I can remove the collet. And for these, the collet needs to squish down quite a lot in order to actually be released. And so these are actually pretty hard to install. If you needed to put on a tip that was nearly the diameter of your collet, you wouldn't be able to really install it very simply, at least not like this. Anyway, so up in here, there is, let's see here, we got this little rubber seal piece. Okay, so this thing here, it's like rubber seal, and then here we have this. So this is a 3D printed plastic part. There's a $15 gas spring ejector from McMaster Car. There's a 25mm knurled knob with an M6 female thread. So the end of this ejector has a M6 male thread, and this was just something I had around, and that ejects it. So, you know, as the subspindle grabs onto the part, it compresses this. And I think Royal makes the subspindle parts ejector similar to this, although they want like $700 for it. I'm sure it's better. This was 15 bucks. So anyway, but the whole point of this video is that Doosan supplies these machines with a very sophisticated and very nice pneumatic parts ejector, and that whole assembly is back up in there. And in fact, if it wasn't back up in there, I would change the shape of this a little bit, or I would use a longer gas spring. I designed this so that it would fit in there without removing that whole gas pneumatic cylinder ejector assembly. It's kind of hard to show that. I've had it apart, so I'm pretty familiar with it. But anyway, what this does is that this mounts to the chuck, and the chuck spins. So this spins with the chuck, which means that this can contact your workpiece. And in the case of a part with a big open hole, they can spin together and this can plug the hole. The way that Doosan ships these machines, the whole gas spring plunger assembly, that does not rotate. It's mounted to the backside of the hydraulic actuator, and there's a long rod that comes up and it's supported with a little bearing, and it floats in there and it doesn't spin while the chuck spins. And so when you fire that M code, it pushes out and it retracts. But if you were to have any contact between your part ejector and your part in the cycle with the Doosan ejector, it would rub. It would be bad news. You know, this goes to 6,000 RPM. You can't have them rubbing. So anyway, the fundamental difference here is that this one can make, and it does make, positive face contact during the machining cycle, and that creates a dam that keeps the chips from flowing in. And so I'm playing with this, and I think I'll be using this more and more, or something like this more and more, for my through-hole parts to try to keep the chips out of the subspindle, because I found that these collets in particular are really bad for reclamping on chips. It's a really big problem if you can't grab your parts reliably without impressing chip impressions into them. And so this is sort of my attempt at dealing with that. On parts that do not have a through hole, I quite like the Doosan system. It works quite nicely, actually. It has a magnetic sensor and a ring, magnet, and whatever, so it can make positive, it can do a check to make sure that the thing made its full stroke and it retracted, which is good for process reliability in my opinion. If it doesn't make the full stroke when it's trying to eject the part, then it will hang on a fin code and you will have a red light on your signal tower and the machine stops, which is a safe failure mode. I kind of like that. This doesn't have a safe failure mode. Bad things could happen if it somehow failed to eject or whatever. So anyway, this is just a 3D printed housing. I could make these out of metal. I might do that. And I did these 3 slots in here just so that I could still use the through-spindle coolant out of the subspindle if I wanted to. Although in this configuration, you know, that would block the flow of coolant through the center, but I guess while it's grabbing on the next one, the coolant flow could still make it out around this. So I just wanted to share that. I'll probably post more about this in the future as I learn more, but that's been a big problem with this machine. And every lathe is built a little bit different. I know Nakamura has a hydraulic subspindle ejector option. I know Haas machines don't come with anything, is what I've been told. You know, you can buy that ejector from Royal. They're all a little bit different, and none of the manufacturers really outline the specifics of that. And the sales guys don't really know anything about it because the sales guys are frankly idiots who don't know what they're selling. No offense, but sorry guys. But anyway, so I just wanted to cover that and share that.